Hey drivers, there's a lot of VW engine stands out there that are great, but none of them make it easy to get the engine on and off the stand. I have an ATV jack that helps, but it only goes about halfway as far as it needs to. So we've been playing with the welder a little bit and have come up with a contraption that's going to make this a whole lot easier. Or so we think. Stay tuned. Just for orientation, everything's sideways right now, but the idea is to use an air ratchet to spin this lead screw here. You can see it has an effect down here. That will lift the yoke that is on the engine, and if we get everything right, it'll do it smoothly and take the engine all the way from the ground up to a good working height. Let's see if we can make it happen. I've got the top part done. I found these pillow blocks to be good to hold the lead screw in place. And then there's a needle bearing here that'll be supporting the weight. Need to finish the yoke and this whole carriage assembly and then figure out how we're going to make a base for this thing. One of the design challenges is that the engine's kind of wide, and I would like the legs to go under here. There's just not enough clearance for that. The legs will have to be apart by 32 inches to clear the engine, but it should be able to roll right up to it, slip onto the yoke, and lift the whole thing up. It's gonna be neat if it works. For many years now, I've been making brackets in this basic form, welding different tubes together to make different kinds of brackets for whatever I need. And it's worked out really well. It's heavy and it's labor intensive, but it's really robust and can handle a ton of weight. So we're gonna have a high degree of modularity here with the parts we're making. We'll be able to reconfigure and repurpose and all kinds of stuff with the parts that we're making. Also means we'll be able to add brackets for an engine test stand. That'll come next, but right now we just need to get the basic idea done. I think the trickiest part of this whole thing is this carriage. Now keep in mind the yoke is coming out this way. What we want is to be able to lock it in place when it's in position. And so these jam bolts here will do that, pushing on the back side of the upright post and pushing it against this piece that will be welded firmly to the carriage. And so that'll square up. It'll be flat at that point. What I don't want is to put pressure on this roller down here. So I want this roller to have just enough clearance that it's not even touching in this position. Then when we're ready to raise or lower, we loosen up these jam bolts. There'll be downward pressure that way from the weight of the engine, and the whole carriage will droop down a little bit. If I get these dimensions right, the clearance up here will allow the carriage to tilt down, make contact with that roller on the bottom, and miss this piece. Now once I tack this in, it'd be a little more difficult for me to get this thing welded to it. So I think I'm going to do that first. And since this is what holds the yoke for the engine, I'm going to want some jam bolts in it too. So I think I'm going to put one here and one here, this being the top. And that way, if things are tilting under the weight of the engine a little bit, these jam bolts will serve to pitch it back up level again. Trying to think of everything here. I think we have everything positioned as we want it. Right now, it's as if these bolts are cinched down and this roller freely spins. This is the parked position. Now when we need to move, we'll back these bolts off and it'll droop like this. So actually, the yoke would be drooping that way. And now, we clear. And the roller does its thing. Trying to minimize friction here. Otherwise this is going to bind really bad. All of that downward pressure of the engine hanging off the end of this yoke, and it's pretty far out there. I think these rollers are going to be necessary to keep things from binding and hanging up. So hopefully this means everything moves nice and free. This is the parked position where everything is nice and square. These jam bolts back here will be fully extended, pulling the yoke into this upright bar here. This is not when this screw will be supporting weight. It'll be under load when these are loosened, allowing the yoke to droop down and the upright bar here to contact the bearings. And so that's how I want to weld this thing in. Because there's a little bit of a difference here, right? The angle is this way when it's parked, and the angle is this way when it's in movement. That's the angle that I want to weld in this plate at, so that it'll push flat against the nut. I have milled the hole in this top plate here to be long, so that this lead screw can move back and forth within that hole. And it's also just a touch wide. I don't want any friction between the lead screw and this opening. So this is what I'm hoping for, that when we tighten up the jam bolts back here and the yoke moves up, that it'll be moving away from this plate. So this is promising. This is in the moving position. This is in the parked position. How it behaves under load, under a bunch of weight, like we're horizontal here, right? So how it behaves under weight is a little more mysterious to me. But here's just a look at how it would be raising the engine right now. The rollers are turning, that's good. And then we park it, and the roller is free. I can slip a 6/1000 feeler gauge in there. I made this piece and this piece 1/32 of an inch wider than this post. I'm hoping that is enough clearance on the sides here. Okay, yeah, need to take this apart. I need to finish welding this nut to this plate, because that's a keeper. Need to finish welding this plate, weld on the jam bolts, and cap everything off with the other side plate. Then we're going to be looking pretty good on the carriage. I think we have this clamped together in such a way that it has to be square. I just needed to give it no other option. We've built enough to do a proof of concept. Let me show you a little bit better how this thing works. Let's call this the carriage, to borrow from lathe terminology, and it has the yoke attached to it. There's bearing rollers here and bearing rollers here. Right now, they have no load on them because we've locked down the carriage. That pulls it square with this upright bar and off of the rollers. We want to raise the engine, so I'll loosen up the locks here. This is the one that'll matter. As I do this, it lowers down the carriage onto the bearings. And so now everything's kind of tilted down just a little bit, but that's all right for this purpose. The nut that our lead screw goes through floats. And I milled out a little bit of space here for that back and forth, right? So we're as far forward as we're going to be inside that hole there. I don't want to do this by hand. We have an air ratchet. Got it set on low, and it seems to be doing fine. Just for funsies, we'll crank it up. I don't see much difference between going up and down. Obviously going down is easier, but that tells me that we're not loading down the ratchet a whole lot. It's within its capabilities. So when we have all the weight of the engine over there, I hope that we're going to be okay. I tend to think we're going to be fine. Now this is all cobbled together. I need to finish this. I think the carriage is done, and the top anchor, or whatever we want to call this, is done. But need to do the bottom anchor, and then the rest of the base, so this thing can stand on its own and not be sitting here in a vise like this. For the base, we have an interesting problem to solve. We can see it here. I want to have an oil pan, like a drip tray, that's removable. So when it's in place, it needs to extend past the lip on the cylinder head, so that when the valve covers are removed, the drip tray still catches whatever drips out of there. And so that's fine. The problem, though, is this is going to be too tall. It's going to be on top of a wheel, right? So if we have an engine that's sitting on the ground like this, the base will actually have to be all the way out here and clear that valve cover, which then puts the base underfoot. I'll be tripping over it all the time. So what I've resolved to do is make a special bracket where normally the base will run underneath the valve cover when the engine is lifted up, and that's when the drip tray will fit on top of the base when the engine's up and we're actually working on it. But if we need to pick up an engine like this, the drip tray obviously has to be removed anyway. So we're going to make a bracket back here that allows the foot to be moved over and actually clear that valve cover. Now it'll be sitting on top of swivel casters, front and rear, so it should be easy to do that as long as this bracket is strong enough to hold things while jam bolts are loosened up. And I think we can achieve that with some 1/4 inch plate. So let's make one of these and see if our idea is correct. Here's the scribble pad where we've dreamed all of this up, and we're working on this part so that the base can move out, and we'd do a mirror image over on this side so that side can go out also. Basically we're going from being 29 inches wide outside dimension to 32 inches wide in between the two legs. I have enough metal here laid out for one of these brackets, this and like the top and the bottom. Need to cut the sides also, and then cutting some strips to wrap around the thing just for a little bit of reinforcement. This is basically what we're going for. I went ahead and drilled the holes for these jam bolts. A hole here and a hole over there needs to be drilled too, but I want to do that at an angle. I want to spot face a little pocket to weld the nut into so that the jam bolts are square to the tubing when it's in place. So they'll come in at this angle and at this angle. And of course we'll have jam bolts there too. I've cut out some little extra strips here to further strengthen things. You see stuff like this done easier, but something like this on receiver hitches. So there must be something to it. Put one down there too. I really need to make sure that a piece of tubing like this will slide easily into this hole. So the way I'm going to square this up and weld it together is by putting it together around one of these pipes. And I think I'll put some shims in here. I'll just find some shims that I think would provide the necessary clearance to expand these pieces a little bit, but basically be the shape of this tubing. The part that I'm most worried about is the up and down dimension all the way across, and then the left to right dimension just here at this opening, because obviously that opening is quite large. This is basically it, and it looks like I've got gobs of clearance over here. I had to do that so that this could be pivoted, right? This gets wider as it goes crooked, so I'd forgotten that I had to put about 1/8 of an inch over there. Really just needed to worry about the top and bottom, so I'll need to find some sheet metal or something to use as shims. Also want to chamfer these edges so I have a little groove to weld down into. I'm going to do a little bit of grinding. I think I have things all clamped together how I want it. shims are in here and here on both ends, and that's the 1/8 of an inch that we want there. So I'm gonna go ahead and tack it in about 8 spots, and we'll see what this feels like. We need to use these collets to hold these end mills. So I've just switched entirely over to collets, and the Jacob's chuck here is sitting this one out. So I have a 3/8 inch collet holding this 3/8 inch drill bit in. We'll drill this hole at 3/8 of an inch, then enlarge it to a 1/2 inch, and then mill out that pocket. This piece turned out pretty well. It worked like I wanted it to. So based on that little bit of success, we put together the rest of our drawing, which if you can make any of this out, you can see that there's 1,000,000 pieces. Well, I've cut all of the pieces, and now I need to drill 1,000,000 holes. Each one of these takes 4. Same here, 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 and here, and here. On this one, we're actually a little bit tight on space. Our lead screw is going to pass over those jam bolts. I can't put these bolts on this side because this side will be welded to another piece. So it's got to be here. And they need to be low profile, so I'm going to mill out a pocket here just to sink the nut down into the metal about 1/8 of an inch, and that'll do the trick. So I think that's 36 or so holes and nuts that we need to weld on, and jam bolts that we need to prepare. So a whole lot of little steps here. And as we do that, we'll start welding things together, which will be fun to see these things materialize. This is going to go with this. This is going to go with the other one like it. This will go with this. And each one of these is going to get a wheel. It's going to be a lot of fun to try this thing out. some sheet metal here in 2 pieces to make a drip pan. What I wanted to do is slope down this way. So I've cut this pretty tall. It'll eventually be a 1/2 inch high here and go straight across. So it'll be thicker here by, I don't know, 1 inch or so. Didn't have a detailed plan on this one, just kind of going with the flow. Already welded up the corners. Of course, this will have to be welded up. Rhodey's going to help me out with that. And I'll need to weld up the center there so that it doesn't leak. Still haven't decided whether I'm going to do a lap weld or if I want to do a butt weld. The lap weld will give me some reinforcement, so I kind of like that idea. I need to get this thing bent now. I'm going to do some clamping and see if we can get that sloped towards the front.